All right, hello everybody, and welcome to today's concept guide on section 9.3, arcs and central angles. I'm doing this outside. It's a little bright out here, so hopefully you can see okay. All right, here we go. Your objective here is we wanted to define and apply properties of arcs and central angles. We first need to define these guys here. A central angle is an angle whose vertex is a center of a circle. So for example, angle BQY over here, Q is the vertex of the angle, it is the center of a circle, therefore it is a central angle. Another one here, angle AQX, there's plenty of other ones here, XQB, AQY, YQB, we could name these a bunch of different ways even with just these few rays that are going on over there, but it's any angle whose vertex is the center. An arc is an unbroken part of a circle. So for example, XB, this part going from this point that's on the circle to a different point that's on the circle, this part of the circle is called an arc. Okay? Another one would be BY, arc BY. You could also name it arc YB. And notice the symbol that we're using here to identify arc XB as opposed to like segment XB. And there are multiple of those in any circle. In fact, there's an infinite number. In circle Q, two arcs are formed by the points A and B. The one that you notice first is this one. AB is the minor arc, meaning it's the smaller one. Well, if there's a minor arc, that implies that there's also a major arc. Well, where is it? It is arc AYB. It goes the other way around the circle. So the shorter distance between 2 points is called the minor arc. The longer distance around is called the major arc, which is kind of self-explanatory. The endpoints of an arc are, or if the endpoints of an arc are on a diameter, then that's called a semicircle, which is a term that you are already familiar with. So there's two semicircles at the end of any diameter. One that goes one way around, and the other that goes the other way around. All right, this next piece here is important. There's actually two different types of measures of an arc, but we're going to be talking about I'll explain what I'm talking about here in just a second. The measure of a minor arc is equal to the measure of the central angle. This means it's always less than 180. If it's minor, it's always less than 180. So, for example here, if we have angle MAB, well, I'm sorry, not MAB, the measure of arc AB is equal to the measure of its central angle. So this central angle here, of course, is marked as a 90-degree angle, which means we'll say that the measure of arc AB is 90 degrees. Now what I want to distinguish is that's different than the length of the arc. Arc length is different than the measure of the arc. The measure of the arc is like an angle. The length of the arc is something very, very different that we're not talking about right now at all. The measure of a major arc is 360 degrees. That's something that we haven't talked about yet, really, but a circle going all the way around is 360 degrees, but it's 360 degrees minus the measure of its minor arc. These measures will always be between 180 and 360 degrees. So, for example, what's the measure of arc AYB? That goes from A to B. Should have a little mark here for arc AYB. What does this measure? Well, it's going to be equal to 360 minus 90 degrees. Its measure is 270 degrees. Go ahead and pause pause the video and see if you can do these, answer these 4 questions. We'll talk about them in class. Okay, adjacent arcs of a circle are arcs with exactly 1 point in common. Adjacent, of course, means next to. So in this example above, an example of adjacent arcs WX and Y or WY are adjacent arc. They share point W, WX, and that is totally wrong. Hold on just a second. It shouldn't be WX and WY. It should be WX and XY. Let me correct that. WX and XY. Let's see if I did this next one right. WX and WZ. Now that one makes sense. They both share arc W. WX and XY are adjacent. WX and WZ are adjacent arcs. Now the arc addition postulate is one that is intuitive. The measure of an arc formed by two, or as it says, adjacent arcs is the sum of the measure of these two arcs. So all that is saying is this: if you know the measure of xw and then know the measure of wz, then the measure of xwz is the sum of those two. So here's some examples of the types of questions you'll be doing. I'm going to go through this as quickly as I can here. What is the measure of BC? BC, the measure of the arc, is equal to the measure of the central angle, so that is equal to 32 degrees. The measure of CBA, the same thing applies. CA is a diameter, so CBA is a semicircle. Its arc then is half of a circle, 180 degrees. The measure of DOC, this is angle DOC. The measure of the central angle is equal to the measure of its arc. So DC is equal to 58 degrees, DOC is equal to 58 degrees, or angle DOC is equal to 58 degrees. What's the angle, what the measure of arc BD? Well, if BC is equal to 32, CD is equal to 58, then the sum of those is 90. Arc BD has a measure of 90 degrees. The measure of DA, just like we can add, we can really subtract here as well. CD plus DA have to equal the semicircle here of CDA. So 180 minus 58 will be 132 degrees. That's the measure of arc DA. The measure of angle DOA will be equal to the arc DA, so that's also equal to 132 degrees. And finally here in these examples, measure of arc DBA, this arc that goes all the way around here, it's going to be equal to 58 plus CBA, we know is equal to 180. So 180 plus 58 is what that's equal to 238 degrees. Now I want you to flip the page and try some of these on your own. Okay, here come some answers. Check these with yours. Be ready to talk about, or if you can't figure out what's going on with them, we'll talk about them in class. Do the same thing with questions 16, 17, 18, 19. Keep in mind that some of these markings mean that angles are congruent. Keep in mind that you'll have maybe some supplementary pieces up in here, and answer those questions as well. All right, check with these answers here. Next piece of the puzzle, congruent arcs. And at this point in time, I would like for you, if you're paying attention, draw like a Noah's Ark over to the left-hand side of this. Any kind of boat will do, really. So I'll know that you're paying attention. This rule here, or the definition of congruent arcs. Arcs in the same circle or congruent circles that have equal measures are congruent. Congruent meaning that they have the same measure, the same size, the same shape. So how do we know that, or if AB, arc AB is equal to BC, and we know that because the central angles are congruent, okay? We have that established. If circle R is congruent with circle Q, that means their radii are all the same, which, see how it's marked as the same? So therefore, these circles are congruent. Then if the central angles are congruent and the circles are congruent, the arcs are congruent. If they're in the same circle with the same central angle, the arcs are congruent. If these circles are congruent and then they have the same central angle, then the arcs are congruent. In this example here, AB is not congruent with ST. Why? Because ST is in a different circle. This circle has a different radius. It's a smaller radius than these other circles, so they are not congruent arcs. They have the same measure, but they're not congruent. They're not the same size and shape. Kind of like they're kind of like similar triangles versus congruent triangles. These are not congruent. They're the different size. So the measures of arcs are more like the measures of angles. Okay, last piece of the puzzle here. This will be kind of intuitive, I hope. In the same circle, or in congruent circles, two minor arcs congruent if and only if their central angles are congruent. And that's, we're talking about this just above here. So if you're talking about the same circle or congruent circles, the key being the radius has to be the same. And of course it is if it's the same circle, but with congruent circles. So in this example, if angle 1 is congruent to angle 2, then if angle 1 is congruent to angle 2, then the arcs JK and the arc ML are congruent. And then the converse of this, notice this an if and only if, so the converse of the statement is true. If JK is congruent to LM, then the angles have to be congruent as well. You can go either way with this. So in this last set of examples, you're going to have, we have a circle, and then we have a bigger circle. So we'll have some congruent angles, but not necessarily congruent arcs. See if you can answer these 6 questions. I'll show you the answers in just a second. But pause the video first and do it yourself. Okay. True, false, true, false, true, false. All right. Come prepared with questions if you have any, but hopefully this is making a little bit of sense so far. We have a huge, huge day tomorrow. Get some good rest. Thanks, bye.